Good morning, guys. So we're going to graph and solve rational inequalities. So before this, we graphed rational functions, and so it's good to get an understanding of that before moving on to this, because basically once you can graph it, you just use the graph to find your solution set. So let's start with x squared plus 3x over x squared minus x, which is greater than or equal to 0. So the first thing I always do is see if there's anything we can factor out to further simplify our function, and also to see if there is a common factor between our numerator and denominator. So here we see that all of our terms have x in them. So I'm going to factor out x. And what I get is this. And so x cancels out. And so we're left with our simplified function. Okay, so when we have a common factor between the numerator and denominator, that means that there's going to be a hole in our graph. And so for our hole, the x value of our hole is going to be 0, because when we cancel x out, between our numerator and denominator, it's going to be 0. And so now that we have the x coordinate of our hole, we need to find the y coordinate. So to do that, we're going to plug in our x, which in this case is 0, into our function. So when we do that, we're going to get -3. So -3 is the y coordinate of this. So this is our excluded value. So 0, -3, we can put a circle on our graph here, and that shows that that is not included in our solution set. Okay, now let's keep going. We're going to find the vertical asymptote. So to find that, you're just going to take the bottom and solve for that. So okay, so our vertical asymptote is 1. So let's draw that at 1. And then let's find our horizontal asymptote, which, looking at our function, the degree is the same. So it's the same here, it's the same here. So what that means is we're going to take the coefficient of our numerator, which is 1, over the coefficient of our denominator, which is also 1. And so that means our horizontal asymptote is 1. So let's draw that over here. Okay, so now we need to find our X-intercept. So to find our X-intercept, we're basically going to solve the top, and the reason for that is technically we solve the whole function, but when we set it to 0 and try to get rid of the bottom by multiplying our denominator on both sides, it cancels it out, and this side doesn't change. So it's really no different than just solving for our numerator. And when we do that, we get x equals -3. So that's our X-intercept. So since we know for sure that's going to be a part of our solution set, we're going to draw a filled in dot. So now we need to find our Y-intercept, and our Y-intercept is when x is 0. So we're going to put 0 in to where we see x. And when we do this, we get -3. So -3 would be our Y-intercept. But if we look at our hole, -3 is one of our excluded values. So since these two are the same, it's referring to this point, which means our graph will cross here, but it will go through like this, but it will not include that point. So in this case, we just have no Y-intercept. So now we have enough information to graph our graph. So we know it has to cross through here because that's one of our zeros. So It's going to cross for sure through here, and it's going to go through here. It's not going to include this point, but it will continue past it. And these two ends will get really close to our vertical and our horizontal asymptote, but it's not going to actually touch it. And so we see we have this over here, and now this side, it can't be like this because that's going to give us an extra 0, which we don't have. So it has to be up here. Okay, so what this function is saying is x plus 3 over x minus 1 is greater than or equal to 0. So let's find where that is. Greater than, this for sure is greater than, and this is, and we are going to include this dot because it's greater than or equal to. So now that we have that, we can write our solution set, which is basically your domain, which is the stuff corresponding to the x-plane. So over here, it's going to keep going this way, so we know it's going to be from negative infinity, and it will go to this point, which is negative 3. And since it's greater than or equal to, we're going to do bracket because we're going to include that negative 3. We're going to include this point. Okay, so now these are not a part of our solution set because they are less than 0. And so our solutions are going to go skip to these over here. So union, it's going to not include our vertical asymptote because it never does. Your asymptotes are never included in your solution. So you're going to leave off from your vertical asymptote, but you're not going to include it. So we use parentheses, and that would be 1. And it keeps going this way, so it will go to infinity. So our solution set, we have negative infinity, so negative infinity, and then it goes to 3, but it's going to stop, and it's going to jump. It's going to jump to over here, not including this asymptote. It's going to keep going, and it will keep going from there. So our x values, or our solution set, continue from infinity, stop, jump, and then continue. So that's how you do that one. So let's do another one. This time, it's going to be negative x squared minus x over x squared minus 9, which is less than 0. So first thing, can we simplify this? We can't. There's nothing we can do, so this is the simplest form it can be in, so we're going to continue from here. So I always like to find the asymptotes first. So let's start with vertical. You are solving for the bottom, so x squared minus 9. Okay, and now using our square root principle, it's going to be x equals plus or minus the square root of 9. Square root of 9 is 3. So x is going to be 3, and x is going to be negative 3. So for this problem, you have two vertical asymptotes at 3 and at negative 3. Okay. Now let's find our horizontal asymptote. Okay, so the degree is the same, so coefficient of the numerator and coefficient of the denominator, that gives us negative 1. So we're going to draw negative 1. Okay, and now we're going to do our X-intercept, which is solving for the top. We're going to set it to 0. Okay, so here, when we have two products that equal to 0, we know that at least one of them has to be 0. So one of our x's is going to be 0, because 0 times doesn't matter, is going to be 0. So one of them, x equals 0. And for the next one, let's look at this, x plus 1, which means x equals -1. So we have x equals 0 and x equals -1. So let's plot our x-intercepts. We're gonna fill our dot in because we know for sure it's gonna be a part of our solution set. Okay, now let's find our y-intercept. Y-intercept is when x equals 0. So let's plug 0 into our function, into where we see x. So when you do that, I'm gonna get 0. Okay, I'll write out the whole thing. And when you do that, you will get 0 because oh wait, hold on, I forgot a 0. There we go. So 0 on the top just equals 0. So our y-intercept is 0, which we already have plotted, so we don't need to worry about that. So now we have enough information to graph. So you could make a table and plug in values to find the end behavior, or you could just use common sense. So it can't go like this because it's gonna cross x, which we don't have. Same thing over here, it can't go like this because it crosses x. And you know it's gonna cross the x-intercept at the x plane at some point, because it has to get close to your asymptotes, and it can't do that. So it's gonna be down here. So we see it doesn't affect our zeros when it's down there. And up here, you can't do this because you can never cross either one of your asymptotes. So it's gonna have to be going up. Oh, okay. Okay, good enough. So this is our rough sketch of our graph. And now we need to find what our solution set is. So we see here it's less than 0. And so what that means is what we did up here is kind of useless because it's just going to be under that. Yeah, so that's going to be our domain. So we write it. Our solution set is our domain. So it keeps going this way. So it comes from -infinity to our asymptote, which is -3. And it's not going to include that, so we're going to use parentheses. Then it will go to 3. So we can see what we did here matches up with what we highlighted, which means -infinity is going to come from -infinity. Oh wait, hold on. Let me do this on the x. And then it's going to stop. And it's going to jump to over here where it leaves off, and it's going to keep going. So we see that matches up with what we did here and what we did here. So that's for that one. Now let's do another one. Okay, well, I'm just gonna draw another graph because I forgot to. Okay, so now we're gonna do we're gonna do x squared minus 4x over x squared minus x minus 2, which is greater than 0. So let's simplify. Let's take our x out. Now, how are we going to cancel out either one of these? I'm going to factor out the bottom. Okay, so plus 1 and negative 2 are factors of negative 2 because negative 2 times 1 is negative 2. And they add plus 1 minus 2 to make negative 1. Okay, so we can cancel. Doesn't look like we can cancel anything out. Okay, well, let's keep going and see if this will be any use to us. It'll be useful when we try to plug in x because we just know the top will just be 0 for the y-intercept. But anyways, vertical asymptote, we're going to solve for the bottom. So it's just going to be negative 1 and 2. Okay, so what I did basically is I looked over here and we know x or negative 1 plus 1 is 0, so we know that's one of our solutions for our vertical asymptote. And x minus 2, what does x need to be to make it 0? X needs to be 2. So yeah, another reason why factoring it out like this, especially the denominator, can help make that faster. Okay, so now let's do our horizontal asymptote. So just coefficients, since it's the same degree. So we have 1 over 1, which is just 1, so y equals 1. And let's draw those. So let's start over here, right? So negative 1. 2. And then 1. Okay, so now let's find our X-intercept, which is solving for the top. And we just see from here that it would be 4, but if we wanted to check, we can just solve. Oops. Okay, so yeah, x equals 4, or you can just look here. So we're going to draw a dot and fill it in because we know that's going to be included in our solution set. Now let's find our y. Okay, well, our y, when we plug 0 into x, because for the y-intercept, the x-coordinate is 0, it's just going to be 0 because when we plug it in, doesn't matter what we do over here, this is it's being multiplied. So anything multiplied by 0 is just 0. And when the top is 0, everything is 0. So y equals 0, which just makes it here. Okay, so that's everything we need to graph. So let's graph it now. Let's use our common sense. It can't do that because it's going to give us another x, so it has to do this. Okay, it can't do okay, so for this one, it's gonna do that. It has to cross that point. Now for this one, it can't go up because our asymptotes are never included in the solution. And if it crosses it, then that means that it's a part of our solution. So it has to go down. Okay, so what is this asking us? It's saying it's greater than 0. So for sure, this is greater than 0. And this is greater than 0. And we're not going to include that point because it's not greater than or equal to 0. And so now we can write our domain. See, so if it was like this, then we would include just this point. But it's not. So let's write our solution set now, which is, we see our arrow keeps going this way, so it's going to come from infinity to our asymptote, which is -1, not included. And then it's going to jump to here, which is -4, also not included. And it's going to continue this way to infinity. So what this means is we have it coming from over here, goes to here, stops, and then jumps to here, and then keeps going from there. So that's how you solve that one. And that's it. Bye, guys.